So I want to start assembling this solid state music. It's an IO2 card. We looked at this in a couple of previous videos, and I'm just going to go ahead and start to assemble this. And then we'll figure out, exactly what we're going to build on it, whether it's going to be serial I/O or parallel or whatever we're going to do. And I've got to put some resistors in. I'm kind of trying to get a feel for lead spacing. Sorry for sticking my head in the shot. So 1 notch before 15. There's a 1K ohm resistor here, which is this guy, which provides a pull up from here to here. Coffee out of the way so I don't spill it, because if it can be spilled, it will be. And the flush cutters. And then we've got a bunch of 2.2K ohm, which all go up here. There should be 9 of them. I think 1 notch before the 15 again. Let's free these. We'll try one. For now, I just want to get enough of this card together that we can apply power. I think I'm going to set it up on a couple of ports, and we can just use basic under CPM to peek and poke those ports. And just see if the basic card works. So these are 2.2K ohm. Spacing looks like it's it might be okay. Thought it was going to be a bit narrow, but that looks okay. Try to keep these somewhat even. That's not going to be somewhat even, but such is life. These are pull-up resistors for a dip switch. Wow, that's really not centered well. Oh well. There's the part of me that wants to pull it out of there and re-bend it. Well, it's going to have to pull it out of there and re-bend it, just because I'm really unhappy with how off-center it is. Spend a little more time here, making sure it's centered in the bending tool. That's a whole lot better. Don't expect perfection, but still would like it to look nice. I still plan to turn one of these cards into a ROM board using 1702 EEPROMs, which would be very period appropriate for the Altmon and the bootloader. And you can see here again the value of a lead forming tool. They're inexpensive. They can make things look a little nicer. I'm hoping I have some 8212s in my stock of old Reclaim components. Those are an 8-bit IO port. This would have been better to do here because it centers the part auto-magically, and of course I figured that out on the last part. But such is life. Bend the lead pretty severely there. These again are just pull-ups. I don't think the 2.2K value is critical, although the lower the resistance, the more current there will be flowing, and the more overall current the entire circuit will draw. And one last one. Looks pretty straight. I'm happy with that. Let's go ahead and solder these up. It's kind of an interesting concept. It makes a lot of sense to have kind of a general purpose prototyping board. It's the actual way it's laid out I find really interesting. Just because it's got, you know, prototyping areas in multiple places across the board, instead of all kind of consolidated together. Come on. You know, it's a reproduction board, but it looks like it's manufactured really nice. And it is the blue material that the solid-state music boards back in the day used. So it keeps it kind of authentic looking. It's nice to finally be able to get back on the bench here and do some soldering. The cold I'm still not quite over has really taken it out of me for quite some time, as it has many people here. This has not been a kind cold for anybody who's had it. So that really gets the resistors. We really move on to sockets. So this is the dip switch here. Grab some sockets. That's the wrong box. And we'll just drop some in place. So I've got a 14 pin. Looks like there's a dot by pin 1 on these. 16 pin. I debated whether to actually, I've got some very old school sockets. They're really thick, and so it would make the overall board thickness really thick, which might actually be a problem. There's a 16 there. It looks like there's another 14 here, and I'd like it to at least match the other 14. Let's take a 14 and a 14. So 1, 2, 3, 4, 5, 6 sockets, and then there's two 24 pin sockets for the 8212s. And we'll go ahead and add them just because there's already footprints for them. So the notches here on the piece of paper are used to indicate pin 1. So the notches should all be to the left here, and they are. Hold these in place so I can flip the board over. We will tack a corner pin on each socket. Come back around, make sure they're flush. Nice fat traces for the power pins. That one did not solder well. Looking at the layout of the board, definitely I think hand taped. Which nothing wrong with that. That's how it was done back in the day. I hand taped a few boards all the way back in high school. Typically would get your schematic, you tape the board up typically double size, and then photo reduce it down to the actual size of the PCB. Why isn't that taking solder? I think that's hit every socket. That's the dip switch socket. Let's just go ahead and make sure every socket's flush. That one wasn't quite flush. Neither was this one. You heard the little pop there as it moved up into place. This one I felt it move. And the 24 pin guys over here. When that one pin is really not wanting to take solder. Ow, burnt myself. Okay. Just come along now and you'll notice there's no solder mask on this board. The blue isn't like solder mask color. The blue is actually the color of the circuit board itself, where they're normally green, the fiberglass. This is whatever the material is blue. Like I say, it's what solid state music used back in the day. It made their boards very distinctive. Getting some really poor looking solder joints. Lots of potential to get solder bridges right here. It's got those traces that run directly between the pins. They're nice fat pads. Actually makes me wonder if they took a design for a different board and turned it into this board. which is why there's kind of the hodgepodge or prototyping area spread around it. Not a lot of decoupling caps on the board. Of course, it's designed for a 1 megahertz 8080 system, or 2 megahertz Z80 if you were lucky. So definitely not designed for a real high speed system. Although if you were using regular TTL logic, not like low power, you could get a lot of current being drawn. At times this thing switched, and of course it creates noise on the power supply. Another spot here where I got to be careful or I'll get a bridge. I'm trying to keep the heat away from the trace that runs between the IC pins. I've been saying this for a while. It's still not my best all-time soldering job. Got some solder joints I really don't like the look of. That's all that core logic. Got one via over there that shouldn't have solder in it that filled up. Gonna have to clear that out. Now, rather than use jumper links all over this, I'd really like to put in posts and wire wrap on the front of the board, the various connections to get things to work. I'll have to look at how to do that, because not all the binding, not all the places you're meant to solder wires into to configure things are on 0.1 spacing looking at it. But we'll tackle that here as we move forward. This should be the last IC socket for now. And for playing with this board, I'll probably use wire wrap sockets initially to prototype, and then either move it back to regular sockets and point-to-point wiring, or maybe just leave it wire wrap. The problem with using wire wrap is the long pins that poke out. Don't leave a lot of room when the boards are in the back plane between the boards. Almost done up here. So that should be every pin. I don't see any bridges. Where there's traces running between the IC pins. So that's not too bad. I do see a spot I'd like to add some solder to, just because it's inconsistent with the other solder joints here on the face. Now I'll heat up the soldering tool. Really trying to think where to go next. Probably pin headers. Let me find the box pin headers. Should have grabbed those in advance. Apologies. Rather than solder wires like directly into these, I think that's the in and out strobe. I prefer to use pin headers. Sure, I've got some gold ones in here. That's tin plate. There's a gold strip. Not that you'd necessarily have been using gold. I reckon that was a nice right angle. There's a gold. Lots of silver here. Not as much gold. This is just kind of a mishmash. Get a good deal on them, I stock up. Eventually you're going to use them. That should be plenty. Get these back into the storage container. Get the lid latch shut so if I drop it I don't spill them anywhere. And those should go right in. I just need 2 groups of 5 for there. And like I say, wire wrapping this on the face of the board will be a nice technique. 5, 6, 7. 2, 4, 6, 7. We'll drop 1 in here. And I think we'll tape those, tack a pin, square them up, and solder. Here, and where'd the others end up? Over here. Those actually look plenty straight. Happy with that, so let's just go ahead and solder them up. This gives you 5 tie points here for the strobe in and the strobe out if you're doing port decoding. I don't actually know what this row down here does. It's got SM above it. Let's run off around the 74L42. It's certainly meant to be able to make connections to, so let's go ahead and carefully, without creating bridges, solder that up. Apologies if I'm off camera. Bridge, no. Of course, the little bits of tape I peeled off are sticking to my arm. And strobe out, strobe. And really, blocks of 3. here. You can see that one of those is crooked. And that's not working very well. This one is definitely crooked. That looks better. Tight little working area. We've got the SM pin there. S0, S1, the enable to add, and what are those for? SM's definitely called out here. See, I'm pointing off page. SM, that single pin's definitely called out there. So I'm going to attempt to solder a single pin down into there. Again, it can be wrapped onto. Hopefully that'll hold it in place square enough. Doesn't look like it's all the way through. Good enough. I don't know. SIN. So serial in, serial out, maybe. Don't honestly know. Need 5 pins. I want to remove one of those pins. It's going to go in, hopefully there. That went in fairly tight, so I think it'll sit in place while I solder it. Yeah, that's okay. I've got a single pin and S out. Looks pretty straight. Find out once it's soldered in. Dip switch. Looks like there actually is room on here for the spiking caps. Looking at some of these there and there. At a minimum. Yeah, it's got room here for some decoupling capacitors. like it's got a spot there for decoupling. Again. I don't really see. That definitely brings ground to there. Pins. Remove the center pin. We have SO and SI, or S0 and S1. It's hard to say exactly. They're not quite 1.1 centers, but it's close enough. It'll solder in. Tweak them slightly to square them up. Yeah, see, and these down here are not on 0.1 centers at all. It'd be really difficult to get pins across all the bus connections if you wanted to pull those out. I see two more spots where really pins need to be put in. There and there. Maybe there. Those are fairly square. Wow, was that a lousy looking solder joint? Along with that and that's cold. Whole slew of really poor solder joints here. Solder didn't flow all the way around the pins. That tip temperature looks good. For those of you that have never seen what wire wrap is, as I talk about it, this is a wire wrap tool. It's got a little stripper in the handle here for stripping the insulation off of wrap wire. I've actually got some wrap wire here. And the intent would be, say I needed to hook this pin here to one of the pins down here. The little piece of wire slides into a little channel in the tool. A little bit of the insulation slides in. I get over the pin and I just spin the tool. And I don't know how well this will show up, but that wire's wrapped onto that pin nice and tight. Now this lead's a little bit long, so I'm going to trim it down a little bit. I'm going to take the stripping tool. I'm going to kind of eyeball about where I need to strip the insulation off. That's a little bit long. And same thing into the channel, onto the pin I want to be connected to. And I've got a nice electrical connection between those two pins. The posts are square. They have square edges to them. And those square edges basically cut a little bit into the wrap wire and create a gas-tight connection so they don't oxidize. These are considered real high reliability joints. And if you want to undo it, I've actually got an unwrapping tool, but you can just spin the wrapping tool backwards and it loosens up the wrap and the wire comes off and you're done. So playing with this, reconfiguring that kind of stuff, that'll make it really easy to do. And I've got a huge collection of colors of wrap wire that I've collected over the years, so I can keep buses and things the same colors. And with all that said, a wrap socket might have made real sense in one of these positions, because I could wrap onto the data pins to bring out and across. I may end up replacing one of these sockets. There's just so many odd places there's extra holes, and I don't know why. But we've got 4 here. Look, they can be used for. I'm going to have to really go through the schematics and look at this and document what all these positions are. I think that's a little bit crooked. And it is. See if I can get it to go down and straight. That's better. Again, gives me 4 tie points there, which are pulled high by that 1K ohm resistor. And it goes off to, I'd have to look at the other board. One of the pins on this socket. Well, let's chug along for a fair part of that. We want to put in some bulk decoupling caps. It actually looks like these were bent at the same side. These are 22 microfarad 35 volt that were bought for a different project. And it looks like I have an excited dog. And it looks like when I bent the pins on these for the other project, the spacing was, well, relatively close on one, but there it is. So that's deep bulk decoupling for where the 8 volts come in, and then where the 5 volts goes out from the regulator. We can go ahead and tack those down. No clue what the dogs were barking at down there. They were certainly barking. Gonna touch up the solder joint here on the top. It started to flow through, but didn't do a very good job of it. Just to make it look a little bit neater. We got a 7805 that goes on here. So let me pull out a voltage regulator. A little heat sink of some kind. One that's somewhat low profile. Sorry, still fumbling through heat sinks. The wrong package. And it's too big. That's really too large as well. I'm not convinced one of these little ones is going to be enough, but I think that's what we're going to end up using. So this large pour here is ground. And that one's insulated or isolated. This is an old Tandy Radio Shack 7805, it looks like. I've had forever. It's somewhat appropriate to this application. Comes with a little shoulder washer and a little mylar. And let's just make sure it says 7805. Well, it says HEP C6110. I'm going to assume that's a 7805. I did write 5 on it when I cut the package down. I want to bend that lead right about there. And this lead will get bent in the same place. Screw hole is lined up nearly perfect. And this one's going to get bent right about there. Heat sink up underneath it. I've actually got some heat sinks that are more appropriate. That package won't even fit in this heat sink. Just the heat sinks I want aren't up here. It's not going to work. Trim these ears off, they're not needed. Wow. I think I need to insulate this. Power on. those. My meter didn't seem to want to come up. So this big trace is ground. With the device out, I know the center pin is ground. Okay, that's fine. So that can be connected through to there. It's not going to be an issue. It's not like a negative voltage regulator where that center pin, I don't believe, is ground. Very long bolt or screw. There's plenty of room for the lock washer to drop in. And the little nut to get spun down on. I kind of like stuff to be square. That's somewhat close. Of course, I don't have a convenient flat blade floating around here. It's pretty square. I will definitely power this up and verify the regulation before I actually put ICs in the sockets. And I'm going to solder this up from the front as well to get as solid a connection as I can. Not just rely on the plate through. Not bad. There should, however, be some additional decoupling, and it's there and there. I want to pick up the little bits of extra hardware here because they need to go back into storage before I lose them. And there's another shoulder washer here. When you need the micro washers, you definitely need them. They're definitely worth holding on to. So we're after a couple of 0.1s. It'll somewhat look appropriate on this. These are interesting. Motorola 0.1 35 volt 7th week of 81. I'm assuming those really are capacitors. Oops. Solder that one, and then we'll tackle the other one. I don't know that the lead spacing is the same. Looks like actually it probably is. What it looked like was just kind of the width at the tip of the needle nose. Bring it back down flush. Was enough that it fit fairly well. These old voltage regulators definitely need the capacitors around them to keep them from oscillating. So definitely want to include them in the circuit. So we're definitely chugging along here. Let's dig up an 8-position dip switch. Some more stuff away. Pin headers can go back in their box. We'll locate the dip switches. Let's see if we can find a suitable one. Where's the dip switches? Switches. Dip switches. This is a mix of new old stock and pools. It's an 8-position. Got lots of these that I got surplus, pretty inexpensive. That's not too bad. That looks like it's new old stock. On is up. To me, it's going to be upside down. Let's see what one of these would be like. Off. It looks like it'd be upside down again as well. Not finding a lot of other choice here. Ouch. Okay, needle nose. Oh, that's the same part. On. It's going to hook it up to the ice. Yeah, so I guess any one of these, it doesn't matter. It's going to be in. I prefer it in where 1, which would be pulled up, is high, and 0 is going to hook up to the logic or the ground. Is that actually a ground there? It is. Yep. Bottom row is a ground. So I can see here now I need to pick up those 8 holes because they get wired off. And we didn't do that. Pin headers again. Hopefully I can get a pin header in there. It'll work. It's actually kind of funky. There's the 4 that come off to the IC down there, and there's the 5th one. Okay, that does make sense. I think I'm still going to put the pin header in there if I can get one in, just so I can easily wire wrap off of it if I need to. Let's see if we get lucky. We really don't. Okay, this is going to be a little bit tricky. First off, I need to clear one of the holes out here. Which is this one. Got it. Don't know if I can make this work or not. Have any chance of these being in any kind of alignment. And of course, the one that's a little bit stiff shook loose. I'm more and more thinking this isn't worth it. Because really you're worried about the 5 upper bits. And those already come off to the decoder IC. So this is really A15, 14, 13, 12, 11, 10, 9, and 8. And you're really only worried about the 8, 15, 14, 13, 12, and 11, because you decode that back down to either a block of addresses or to a block of ports. And the board's designed to, once you get your block of ports, there's going to be 8 ports decoded on the board. So down's going to switch it to ground, so it's matching a 0. Up is going to pull it up to a 1. And I just need to ignore the numbers on the dip switch, as much as I hate that. Since this one's new old stock, I'm going to assume it's good. If it was one of the pools, I'd actually be checking it out with the ohm meter to make sure that all the contacts inside of it work before I soldered it in. Because it's quite possible when you pull one of these that you damage that little switch inside. I've done it. So always worth testing before you solder in. And honestly, if it's a pull, you want to test after as well. Nice gray solder joint, should be bright silver. So we've now got our dip switch in to set our ports. So really the bottom three switches don't matter, so that would be ports 248 to 250 or 255, so 247 to 255 decimal. All of them down would be ports 0 to 7 decimal. And then with the switches, someplace in between. The 1 of 8 decoder that comes off is this 1, 2, 3, 4, 5, 6, 7. Thought it was this guy. It's only got 7 pins. I don't remember. I'd have to read again. But the decoding becomes a set of pins here that you can then take to the chip enables on various devices. But I think for that video, this is enough assembly. Definitely making progress. I think it looks pretty nice. It's going to be a great addition in my machine. It's unique looking, which I like. If you got this far, I appreciate your watching, and we'll talk soon.